Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of x equals x. Now what I'm first going to do is I'm going to divide by x on both sides. So we have x to the power of x equals x, and if I divide by x on both sides, well, first off, on the right side, x divided by x, well, that's simply 1, because anything divided by itself is 1. Now, on the left-hand side, we have x to the power of x divided by x. And x here, our denominator, this can be written as x to the power of 1. And if you guys recall an important property of exponents, it states that a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So this is the formula for dividing exponents. So right here we have x to the power of x divided by x to the power of 1. And x in this case is a, x is m, and 1 is n. So if we put our variables into this form, we get x to the power of x minus 1. So now we're actually going to rewrite this as another, before I rewrite this, another important property of exponents is that if we have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of x minus 1, this would equal x to the power of x times x to the power of negative 1. And this is still equal to 1. So now, if I divide both sides by x to the power of negative 1, these two would cancel out, so I would get x to the power of x is equal to, well, 1 over x to the power of negative 1, this is equal to 1 over x to the power of negative 1 is the same thing as 1 over x to the power of 1. So this would be 1 over x. And 1 over x, well, this is simply equal to x. So 1 over x to the power of negative 1 is simply just x. So now we get x to the power of x is equal to x. And now x, the exponent for x is actually 1, right? So we have x to the power of x is equal to x to the power of 1. And as you can see here, we have the same bases for both of these, meaning if we have the same bases, our exponents are the same as well. So that means if we set our exponents equal to each other, we get x equals 1. So we get x equals 1, and this is a solution. However, as you can see here, remember this equation? X to the power of x minus 1 equals 1. Well, I'm actually going to rewrite this as x to the power of x minus 1 equals x to the power of 0. Because 1 here, 1 is the same thing as x to the power of 0. Now, we're going to do the same thing what we do here. We're going to set our exponents equal to each other. So we're going to set x minus 1 equals 0. And if we add 1 on both sides, we get x equals 1. So this is another way of doing it. And actually, we have our solution as x equals 1. However, there is actually another solution to this problem. X equals -1. This would also work as well, because if we plug this into our equation, for example, -1 to the power of -1 equals -1. Well, -1 to the power of -1 is simply 1 over -1, and this is equal to -1, and 1 over -1 is simply just -1, so -1 equals -1. So this is right. So x equals -1. This is also a solution to this equation. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x squared minus 6 squared minus 6 is equal to x. And what I'm first going to do is I'm actually going to set a equal to x squared minus 6. So I'm going to set the variable a equal to x squared minus 6. And if this is true, and if we substitute in a for x squared minus 6, our equation would be a squared minus 6 is equal to x. So now if this is true, and let's say this is equation 1 and this is equation 2. Now I'm actually going to subtract both of these. I'm going to subtract x squared minus a squared. So x squared minus a squared. And what ends up happening is we get the result as a minus x. X squared minus a squared is equal to a minus x. So if we have something in the form m squared minus n squared, this can also be written as m plus n times m minus n. Meaning x squared minus a squared is equal to x plus a times x minus a. And now if I add x on both sides, we would get plus x. And then if I subtract a on both sides, we would get minus a. And now because there's nothing left on our right-hand side, we would simply have 0. So now I'm going to factor out x minus a from this. So x minus a times x minus a, x plus a times x minus a divided by x minus a is simply just x plus a. And x minus a divided by x minus a is 1. So we have x plus a plus 1. And this is equal to 0. So now this would actually give us two equations. We would have x minus a is equal to 0. And for this, if we add a on both sides, we simply get x is equal to a. And if x is equal to x squared minus 6, because remember, a is equal to x squared minus 6 and x equals a. That means x equals x squared minus 6. And if we subtract by x on both sides, so we get 0 is equal to x squared minus x minus 6. Now we have a quadratic equation, and this would actually be simplified to 0 is equal to x minus 3 times x plus 2, meaning our two solutions for x would be x is equal to 3 and x is equal to negative 2. However, there is still another equation. We still have x plus a plus 1 equals 0. So if x plus a plus 1 is equal to 0, that means that x is equal to, I'm going to subtract everything and move it to the right-hand side, negative a minus 1. And I'm actually going to plug in a. A is x squared minus 6, so this means x is equal to negative 1 times x squared minus 6 is negative x squared plus 6 minus 1, and 6 minus 1 is 5. So we have negative x squared plus 5. So now if we subtract x on both sides, we get 0 is equal to x squared plus x minus 5. And if we plug this into our quadratic formula, we get negative 1 plus or minus the square root of 21 over 2. So these are our two other equations. We have negative 1 plus the square root of 21 over 2 and negative 1 minus the square root of 21 over 2.